All right, let's get started with our, this is February-May, paper 6.2, and we're looking at 2021, that's the year, and we're looking at question 6. All right, this is the question about electricity, and the first thing we're asked is to draw the symbol for a voltmeter. Now, to be honest, the mark scheme, we look at it, this is kind of why I record these videos, because I really don't like the way that we are told to do things correctly. Okay, you're asked to connect to draw things correctly, correct symbol and correct parallel connection, but you might not know what that means. Well, here it is. Okay, this is what we're looking for in this question, is a V circle as a voltmeter, and then a correct connection, which is in parallel. And what that means is corrected across these guys, as opposed to in series, which is the case for the ammeter. Okay, so I suppose one way of remembering it is to remember it's the opposite to the ammeter in terms of connection. All right, so that's what we were looking for there. Okay, we're then asked to measure some stuff. All right, and we're actually going all the way down here, okay, to read our meters. Now, these are both analog meters, fairly outdated and something that you may not have encountered in the physics lab. However, you're expected to be able to read them. The way to do this is to look at the divisions. So in this case, between 2 and 3, there are 10 divisions. And so if we're going 2.1, 2, 3, 4, each one is 0.1, so 2.4 is our voltage. In this case, we're dealing with an ammeter of 0 to 0.5 as 25 divisions. You can see that 5, 10, 15, 20, 25. Well, that means each one is 0.02. And we're therefore going a certain number of divisions here. We're going 5 divisions, 10 divisions, 13 divisions. 13 times 0.02 is 0.26. I've just sort of hidden it in there. Okay, so your values there are 2.4 and 0.26. Okay, we'll just have a little look at the other things we have to do here. Okay, it asks you to complete the column heading. Okay, so you've got to enter in your watts. I've entered in a W, and then you're asked to calculate it, and you've got your value of 2.4 times 0.26 equal to 0.62. The equation is given to you later in the question, but there's also one that you will know from the extended paper 4. All right. So we've done that. Okay, we've done our table filling in. We then rearrange the lamps, and this is called circuit 2. We close the switch and we measure our values. Okay. All right, here you can see my calculation down here. Okay, the teacher suggests that if the lamps are identical, the power output of circuit 2 will be 2 times the power output of circuit 1. It then tells you that 2 values can be considered equal within the limits of experimental error if they are within 10%. So we've talked about this a few times in these questions. It comes up and again and again and again. Okay, but in this stage, there's an actual explicit declaration of what is considered constant. So I quite like this question. Okay, to do this then, we're going to have to calculate a percentage difference. And that's actually why this little space is here. It says justify your answers. You're expected to do a calculation. Okay, so what we'll do is we'll double P1, because we're saying if we double the power output of circuit 1, it should be equal to the power output of circuit 2. And we multiply there, we got 2 times 0.62, 1.24. We'll then calculate the percentage difference, and we'll get something about 3%. We're then going to answer the question. Yes, it is within the limits of experimental error, because the percentage difference is less than 10%. And here, hopefully you can see, you're probably a bit bored of me going on about this. We can see why we use this percentage difference, because it's the best way, better than just saying, oh, it's equal or they're almost the same. It really gives you a good quantitative measure to justify your answer. Okay, a student finds that when the switch in circuit 1 is closed, the lamps don't light up. Suggest a check. Okay, well, one thing you could do is check the current reading. Okay, we could check the current reading. All right, check to see if there's an ammeter reading. Okay, other things you could do, we could connect the lamps individually. Okay, or we could connect them in parallel. Okay, there's other ways of connecting this. Really, we want to just check that current reading. Okay, last one then. The student, or last two, and this is a very sort of simple question we're asked. We add a third lamp in series. This is circuit 3. So what we want to do is draw the circuit diagram. Well, we're going to draw our circuit diagram, but not with 2 lamps in series, but with 3. So we've got 3 there in our chain. And it then says we're going to add them in parallel with the 2 lamps in circuit 2. Well, circuit 2, you can see here, we add another one in parallel. And that's what it means by these 2 answers here: 3 lamps in series, 3 lamps in parallel. So a couple of marks there just for doing some correct sketches. Okay, again, pretty nice question, nothing too deep here. Hopefully that's clear, and if you've been looking at the mark scheme wondering what it means, my model answers have been a help. As ever, let me know if you're unclear.